Most students struggle with this Harvard entrance exam question, but the solution is actually hidden in one simple algebra trick. Today, I am going to show you exactly how to find the value of t without making the common mistakes that catch most people off guard. So we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. In the first method, you see here this t is divided by left hand side. When we move it into the right hand side, it is multiplied by this 2 and we obtain 2 times of t. And further in the next step, we move the term 2t from right hand side to the left hand side and we obtain t cubed minus t, and this will becomes minus 2t, and this whole equation is equals to 0. So further in the next step, we need more simplifications and it will be written as t cubed and minus t and minus 2t becomes here minus 3t, and this whole equation is equals to 0. Further, you see here both of these two terms involve t, so we will be take common t from here and we get the remaining values are t square minus 3, and this whole equation is equals to 0. So we divide this equation into the two cases. The first case is we write t is equals to 0, and the second case is we write t square minus 3 is equals to 0. This is the first root of the given equation, and from here we need to find the other two roots, so that we move minus 3 to the right hand side and we get t squared is equals to plus 3. So further, in order to find the values of t, we need to take square root on both of the sides, and when we apply square root it will be written as in this form. Further, you see here this 2 and this square root are gone and we obtain t is equals to, here when we apply square root on this side we will write here plus minus sign on the right hand side, and we get the value t is equals to plus minus square root of 3. So further in the next step we need here you see that there are three roots of the given equation. So now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of this we need to copy down given question statement. Here it is t cubed divided by t cubed minus t divided by t is equals to 2, and here in this side we will be verified t is equals to plus square root of 3, and in this side we will be verified t is equals to minus square root of 3. So first these two roots and then we verify our third root. So here first we substitute t equals to square root of 3 on here and we check its behavior. So we have this is square root of 3 and its whole cubed minus this is square root of 3 divided by square root of 3 is equals to 2 or not. This is the our claim. So you see that here we need to take common square root of 3 from numerator side, and when you take common this we get the remaining values are square root of 3 and its whole square minus 1 divided by square root of 3, and this is equals to 2 or not. You see that this square root of 3, this square root of 3 are gone, this 2 and this square root are gone, we get here 3 minus 1 equals to 2, and 3 minus 1 becomes 2 equals to 2. This shows that both of the sides are equal. It means that the value t equals to square root of 3 is satisfied our given question statement. And now in the same pattern we substitute t equals to minus square root of 3 into the left hand side. So when you put this value here it will becomes minus square root of 3 and its whole cubed minus this is minus square root of 3 divided by minus square root of 3 is equals to 2. And now in the next step you see that the cube of negative term becomes negative, so we apply here we write this term as minus times square root of 3 and its whole cubed, and here you see that minus times minus becomes plus square root of 3 divided by this is minus square root of 3 is equals to 2. So again, we need to take common square root of 3 from the numerator side, and we get the remaining values are minus times square root of 3 and its whole square plus 1 divided by minus square root of 3 is equals to 2 or not. This is the our claim. So you see that this square root of 3 and this square root of 3 are gone, and we obtain here, you see that this 2 and square root are gone, and we get here minus 3 plus 1 divided by minus 1 is equals to 2. So here we have minus 3 plus 2 becomes minus 2 divided by minus 1 is equals to 2, and we clearly get here 2 is equals to 2. This means that the second value of t is also satisfied our given question statement. And now in the same pattern we verify the third value of t, and this is equals to 0. So when we put t equals to 0 on both of the sides of the given equation, so this will be written as in this form. So this will become 0 cubed minus 0 divided by 0 is equals to 2. So we obtain 0 over 0 form is equals to 2. So 0 over 0 form is usually called that it is indeterminate form, or in other words we say that it is undefined form. So if our left hand side is undefined form, this means that both of the sides are not equal. It means that the value t equals to 0 is not satisfied our given question statement. So we call that t equals to 0 be the extraneous root of the given equation. So here here you see that there are two roots which satisfied our given question statement. So finally we have the solution set of this problem is t equals to plus minus square root of 3. So these are the two solutions, and t equals to 0 be the extraneous root, and this is the final answer which we get here from first method. And now we again solve this problem for second method. So for second method we need to copy down given question statement. Here it is t cubed minus t divided by t is equals to 2. So our second method be the very straightforward or quick method. Here we quickly determine about the solution set of this problem. So first we break this fraction, and it will be written as t cubed divided by t minus t divided by t is equals to 2. So this t and t are gone, and we get here t square minus this t and t are gone, and we get here 1 is equals to 2. And we move minus 1 to the right hand side, and we get here t square is equals to 2 plus 1, and we obtain t square is equals to 3. So for the values of t, we apply square root on both of the sides. So this 2 and this square root are gone, and we get t is equals to plus minus square root of 3. So these are the two roots which we get here in the second method, but in the first method we already verified that both of these two roots satisfied our given question statement. And finally we have the solution set of this problem is plus minus square root of 3. This is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.